Hello. Am I audible?
Yes, sir.
In the last class, we were talking about the geometry of molecules. Okay. We have done so many. So geometry we have talked about. Now we'll talk about the shapes of molecule. Random shapes of molecules. For x equal to 2, we have linear shape. For x equal to 3, if we have 3 bond pair, 0 lone pair, then geometry is equals to shape. When x equals to 3, we have 2 bond pair, but 1 lone pair. Then it is angular, bent, or V shape. Angular, bent, or V shape. Okay. For example, we have SO3 and SO2. Here X is 3, here also X is 3. But here we have all the 3 atoms. Here we have only 2 atoms. There will be a lone pair. So this becomes bent and this becomes trigonal planar. Understood? Understood? Any doubt in this? When x is equals to 4, you can have 4 plus 0, bond pair, lone pair. You can have 3 plus 1. You can have 2 plus 2. So this will be, geometry will be same as shape, tetrahedral, shape we are talking about. This will be pyramidal, and this will be same bent, angular, or V shape. Okay. For example, NH4 plus, NH3, NH2 minus. X will be 4, 4 and 4, but neighboring elements are different. This is tetrahedral. This is pyramidal. And this is NH2 minus. Understood? So we can have different shapes in case of x equal to 4. X equal to 5. Bond pair, lone pair. 5 0, 4 1, 3 2, 2 3. This is same trigonal bipyramidal. This will be square pyramidal. Square pyramidal. Square pyramidal. This will be T shape. This will be linear shape. Okay. We have taken all these examples. For example, we have PCl5. This will be same as that of the shape and geometry will be same. ये स्क्वायर पिरामिड नहीं है, सीसॉ होगा. स्क्वायर तो बनेगा ही नहीं. It will be a seesaw. If we take SF4, again we'll get x equal to 5. This is called seesaw shape. Seesaw shape. Okay. If we take ClF3, ClF3, this will be having T shape. More precisely, bent T shape. Why it is bent? Because of the repulsion from lone pair. Why these are not at equal 90°? Because of the repulsion from these atoms. Understood? If we take XeF2, it will be a linear shaped molecule. Understood? Any doubt in shapes? You have to remember all this. This can be asked. आजकल बहुत simple papers आ रहे हैं, so they can easily ask you these things. Done? Where is x equal to 6? It can be 6 plus 0, 5 plus 1, 4 plus 2. This will be same as octahedral. This will be square pyramidal. And this will be square planar. For example, if we have SF6, it will be a square planar. Sorry, it will be a square bipyramidal or octahedral. If we take XeOF4, then geometry will be same, but shape will be square pyramidal. From one side pyramid will be there, one side lone pair will be there. Understood? If you take XeF4, this will be a square planar molecule. Understood? Anish, it cannot be 3 plus 3. It will become highly unstable shape. That has been not included. For x equal to 3, sorry, x equal to 6, we have to remember one specific example, which is XCF6, which if you calculate it, it will come out to be 7. But you have to make the structure like this. This you have to remember only. First you have to make how you make x equal to 6. But you have to make one lone pair also. This is called distorted octahedral. This is called distorted octahedral. Distorted octahedral. Understood? I have said for XEF6, you will get x equal to 7. When x equal to 7, we generally forms pentagonal bipyramidal. But for this molecule, we have to form it similar to octahedral with a lone pair. Because of lone pair, there will be repulsion and bonds will get distorted. Hence it is called distorted octahedral. Okay, Kinman. All of you understood this now? Structures of oxyacids. This also I told you in redox chapter. Structures of oxyacids. Oxyacids. What are oxyacids? These are the acids of non-metals. They have at least one OH group and one element double bond O bond. All are tetrahedral. All are tetra. All are tetrahedral. ठीक है? Quiz based on come. So you should know all these structures. Okay. Done. There should be at least one element double bond O bond. There should be at least element double bond O bond. Central atom will be bonded to double bond O. At least one should be there. Because of that, it is called oxo. Because of that, oxo or oxy. And acid because of this. Oxyacid, oxo acid. Oxo because of double bond O, acid because of at least one OH group. Okay. H3PO2, H3PO3, H3PO4. All of them are tetrahedral. Make tetrahedral first. Least electronegative element will be central atom except hydrogen. Phosphorus is central atom. At least one double bond O group. How many hydrogen left? 3. 1, 2, 3. How many oxygen left? 1. This will be the structure. This is the particular way to form them. First make tetrahedral, then make double bond O, then provide other oxygens, then add OH group, or you can say H groups. H3PO3, first make tetrahedral, then make double bond O, then provide other oxygens, then put hydrogens. Understood? Any doubt in this? This is called hypophosphorus acid. This is called metaphosphorus acid. This is called orthophosphoric acid. Orthophosphoric acid. Any doubt till here? If we have H4P2O7, H4P2O8, And how to form this?
Excuse me.
Yes.
So H3PO3 is orthophosphorus acid, right?
H3PO3.
Yes.
It was metaphosphorus, no? The in-between oxidation state. You can say it orthophosphorus. You can say that
Yes,
also.
orthophosphorus.
रस बोल सकते हैं. That you can say that also. It is also called metaphosphorus. In between oxidation state are called meta. Lowest one is hypo.
Okay, sir.
Okay. Okay, we know that us is for lower oxidation state, it is for higher oxidation state. H4P2O7. Same thing we have to do. Phosphorus, tetrahedral, double bond O, oxygen. Now we are left with only one oxygen. Okay. This linkage is called pyro linkage. This linkage is called pyro linkage. It is called pyrophosphoric acid. Similarly, next one. So we have to join them. This linkage is called peroxo linkage. This is called peroxo linkage. So it is called peroxophosphoric acid. Understood. Understood, all of you.
So that pyro is including O and phosphorus also, right?
Yes, yes. Whenever we have, for example, we have element O and element. This kind of linkage is called pyro linkage. This
Okay,
kind of
sir.
linkage is formed when you take two molecules and heat it. When you heat it, you remove water molecule from it. So because of that heat, pyro word has come. Understood?
Yes, sir.
Now there are two oxides. Their structures also I am telling you here only. P4O10 and P4O6. How to make P4O10? Make 4 phosphorus Join them with oxygen. Give double bond O to all. Now two oxygen left. Join them like this. Understood? So in JEE main this time there was a question on this. How many POP bonds are there? If you know the structure, then only you can tell about POP bonds. How many POP bonds you can see?
6.
6.
6 POP bonds and 4 P double bond O bonds. P4O6 is again same. So it is almost same, just it does not have double bond O. Done? Oxyacids of sulfur. Try to make them with same trick. H2SO4 again will be tetrahedral. This will be H2SO4. This is H2S2O7. It will should be called as pyrosulfuric acid. It should be called as pyrosulfuric acid. It is also called oleum. Done? This will be called peroxosulfuric acid. It is also called Marshall's acid. This name is important. This is also important. Marshall's acid. Okay. H2SO6. It's called thionic acid. Dithionic acid. Okay. On the same trick, we can form this also. Now, if we talk about H2SO3, it is slightly different because we know it has two OH bond. We know its N factor, it has two OH bonds. So this we have to form OH. Oxo is there. So there will be a lone pair in this. This is H2SO3. H2SO3. Sulfurous acid. Sulfurous acid. Then we have H2SO5. Will form same thing. Four oxygens are there. 1, 2, 3, 4. We will form same thing. Same. After this, we'll be left with one OH group. So this will also have peroxo linkage. This will also have peroxo linkage. It is called peroxo monosulfuric acid. Peroxo monosulfuric acid or Carose acid. Done. Then we have HPO3 whole thrice S3O9. So we have to make a triangle because of phosphorus. We have to give a linkage. We have to form double bond O. There will be 3 OH group left. 3 OH group will left. OH, OH, and OH. All of them are tetrahedral. Copy it fast. First make a triangle, put oxygen in between them, then make double bond O, then give one OH group to all. So structure based questions can come. Make this also. Done. This is cyclo trimeta phosphoric acid. Cyclotrimetphosphoric acid. This is sulfur trioxide trimer. Understood? Then we have chlorine oxoacids. HClO, HClO2, HClO3, HClO4. So again, same thing. Make the tetrahedral first, then form double bond O, put OH, There's only one OH group. For this, this is HClO3. Oxygen OH. This will be the lone pair. So there's a particular way to form these structures. HClO is simply this. Understood all these structures? Understood all these structures? Kinmin, which linkage you are talking about? That POP linkage is called anhydride linkage. Because after removing water, we get it. So this much structures we should know in P block chapter. ये structures आपको आने चाहिए. No, in that we do not have any name for that. Okay, now we'll start the chapter. Fifteen group elements. Nitrogen, phosphorus, arsenic, antimony, bismuth. Nitrogen, phosphorus, arsenic, antimony, bismuth. Okay. General electronic configuration. NS2 NP3. NH2 NP3. Okay, we have talked about it. They are called nitrogens as they are suffocating elements. Now we will read about them. Physical properties. Physical properties. Atomic radii. What we can say about atomic radii? What we can say about atomic radii?
Increases down the group.
Increases down the group. Atomic radii increases down the group. Electronegativity. Electronegativity
down the group.
Decreases down the group.
decreases down the group. All of us know this. Atomic radii, electronegativity, ionization enthalpy,
Decreases down the group.
ionization enthalpy. It is the amount of energy required to remove an electron from an isolated gaseous atom. Amount of energy required to remove an electron from an isolated gaseous atom. It decreases down the group. Decreases down the group. As the size increases, electrons becomes less attracted towards the nucleus, can easily be removed. Okay. Understood? Group 15 elements have more ionization enthalpy than group 14 and 16. Group 15 elements have more ionization enthalpy than group 14 and group 16. Why?
Half-filled p subshell.
Very good. Generally, ionization enthalpy increases from left to right because size decreases, but because of stable configuration, what stable configuration? Half filled subshell, half filled subshell, 15 group elements requires extra energy. Understood? But it decreases down the group. Please mute your mic. All of you done? Electron gain enthalpy. Group 15 elements have very less tendency to add an electron because of their stable electronic configuration. So, electron gain enthalpy is less than both 14 and 16 group elements. Just wait. All of you done? What is the valency of 15 group elements?
3.
Valency is 3. What will be covalency? Covalency. What do you mean by covalency? Maximum number of bonds that can be formed by an element. Group 15 elements can have of 6 except nitrogen, as it does not have vacant d orbitals. Vacant d orbitals. As it does not have vacant d orbitals. Okay. So covalency can be 6 or it can be 4. For second period elements, for all group, it will be 4. For other elements, for all group, it will be 6. Nitrogen second period element has a covalency of 4. Nitrogen can maximum form 4 bonds. Other elements can form 6 bonds. So their covalency is 6. Understood? Understood. Different type of questions can be formed on this. That we'll see later. Copy it fast. Oxidation state. What oxidation state they can show? The 15 group elements. What oxidation state they can show? Their general electronic configuration is NS2 NP3. So either they can lose 3 electrons to attain noble gas configuration, or they can add 3 electrons to attain noble gas configuration. So oxidation state is from -3 to +3. From -3 to +3. Tanesh, what do you want me to explain again? Tanesh, covalency. All of you have written till oxidation states?
Yes, sir.
Okay. See, in covalency, general electronic configuration is NS2NP3. So let this be NS, let this be NP. This is NS2NP3. So because of 3 unpaired electron, it can form 3 bonds. 3 unpaired electrons. So 3 bonds. ये तो सबके लिए हो गया. Now, if we talk about second period, and we talk about third period, in third period, there will be 3D subshell as well. If this electron excites to here, then we can have 5 unpaired electron, and we can form 5 bonds. We can form 5 bonds. But second period elements do not have D subshell. Second period elements do not have D subshell. So this electron cannot be excited. It can only be taken as lone pair. it can only be taken as lone pair and can form a coordinate bond. So we have 3 covalent bond, 1 coordinate bond, overall 4 bond. Tanish, while in all other elements, electron can be excited, so 5 single bonds, 5 bonds. Sorry, 5 unpaired electrons, 5 bonds. Understood? Copy it fast. All second period elements can have maximum of 4 bonds. All other elements down the group can have 6 bonds. Done. We were on oxidation state. Nitrogen, phosphorus, arsenic, antimony and bismuth. Nitrogen cannot show +5 oxidation state. Make it from -3 to +5. -3 to +5. 5 electrons can be donated, 3 electrons can be accepted. 5 electrons can be donated and 3 electrons can be accepted. Nitrogen cannot show +5 oxidation state. Why? Why nitrogen cannot show +5 oxidation state? Because it does not have vacant d orbital. Understood? So cannot form 5 bonds. All of you understood this? All other elements can show, like this will be possible from -3 to +5, -3 to +5. This will be -3 to +5, -3 to +3. Copy it fast. So we have to read about nitrogen and bismuth. Nitrogen will show +5 oxidation state only when it forms a coordinate bond. A coordinate bond. Because coordinate bond gives +2 oxidation state to nitrogen. Nitrogen will show +5 oxidation state only when it forms a coordinate bond. For example, this. Do we know how to calculate the oxidation state? We know how to calculate the oxidation state. Am I audible? This is -2, this will be +2. This is -1, this will be +1. This is -2, this will be +2. So it becomes +5. Nitrogen will only show +5 oxidation state when it forms coordinate bond. Otherwise, it's not possible. Any doubt to anyone in this? Any problem to anyone in this? So nitrogen generally forms only 4 bonds, and when it forms one of the bond as coordinate bond, then it can show +5 oxidation state. What about bismuth? Why bismuth does not show +5 oxidation state? Why bismuth does not show +5 oxidation state? Why bismuth does not show +5 oxidation state? Very good, Sahil. Bismuth does not show +5 oxidation state because of inert pair effect. Because of inert pair effect. What is inert pair effect? What is inert pair effect? It is the reluctance of s orbitals. The reluctance of s orbitals to participate in bonding due to poor screening and shielding by D and F subshell. Due to poor screening and shielding by D and F subshell. Copy it fast. Done? What does it mean? If we talk about bismuth, bismuth is 6s2 6p3. bismuth is 6s2 6p3. It must be having the configuration like this. That means these subshells are already filled. They are present before it. So it do have a vacant orbital. It do have a vacant orbital, but because of poor shielding, it can't be excited. Because of poor shielding, these electrons are attracted towards the nucleus. Because of poor shielding by the intervening electrons, 6s electrons are attracted towards the nucleus. They can't be excited. Are you getting it? Because of poor shielding by D and F subshell, the nuclear charge cannot be shielded and the 6s electron will remain attracted towards the nucleus. If they can't be excited, then bismuth cannot show +5 oxidation state. It is very important thing. All of you understood this? Because of poor screening and shielding by D and F subshell, 6s electrons remains attracted towards the nucleus. As they remain attracted towards the nucleus, they can't be excited to 6d subshell. Hence, there cannot be +5 oxidation state. Understood? Understood? Inert pair effect is very much important. Am I audible?
Yes, sir.
Yes, sir.
All of you understood this? Why bismuth cannot show +5 oxidation state?
Yes, sir.
So if we have question, NCl5 exists, but PCl5 exists, NCl5 does not exist. Why? Then what will be the answer?
Nitrogen cannot show +5 oxidation state.
Okay. Anything else? Don't say it does not show oxidation state. It can show oxidation state with coordinate bond. You can simply say it can never form 5 bonds because nitrogen covalency is 4. It can never form 5 bonds. Understood?
Yes, sir.
BiCl5 does not exist but PCl5 exists. Here what will be the reason? Here we can put the oxidation state. Bismuth cannot show +5 oxidation state due to inert pair effect. Due to inert pair effect. Understood? Bi +5 is an oxidizing agent or reducing agent. Bi +5 is an oxidizing agent or reducing agent.
Oxidizing.
Bi +5 is unstable, want to reduce itself to Bi +3 because of inert pair effect. Hence, it is a good oxidizing agent. Understood? Understood? pH 5 does not exist, but PCl5 exists. Why? pH 5 does not exist, but PCl5 exists. Why?
So phosphorus and hydrogen have same electronegativity.
Very good. Cl is an highly electronegative atom, can easily excite hydrogen, can easily excite phosphorus to its maximum oxidation state. To its maximum oxidation state. Okay. Now it's not working only. So we stop class here only. Rest we'll do in the next class. Write down oxidation state.
Thank you, sir.